Well, I thought I'd have a little talk about the new design that I made. You see, there's nothing technically wrong with my new design with the drawers and everything, but I was trying to make use out of, I was trying to save money, and all these coils in this container I actually wound about, what, 5, 6 years ago, or was it 5 years ago? I wound them for a different project, and I never actually used them. I was winding them for. This is what happens sometimes. I get into a bit of a swing of making coils, so I wound all these coils, and I never actually got to use them. As you can see, most of them I've never even what was it? I never even soldered the wires on most of these things. So anyway, I thought, well, I'm going to use these coils and try them out in my drawer system, and right, and well, yeah, it's less efficient, and I kind of expected that. My trigger coil isn't so bad, but there's improvements I can do with the trigger coil. And thermally, there's still a problem because the issue is the reason why I was redesigning all this stuff is because I had a thermal problem where the original coils were melting, and if you remember, the other video I did the other day, as you can see, they're basically melted. And yeah, I used some plastic stuff to as some epoxy to glue them back together again, which is why they're in such a mess. But these coils actually work pretty well, considering they did do quite a good job. So I'm thinking, I've been doing a bit of thinking well, I went to bed last night, I slept, and I was thinking, well, why don't I just use my lamination arrays, which I've been working on to overcome drag and everything, and basically build a coil around my lamination arrays, because these have very good pull and push properties for the magnet drums and very low drag. So this is what I'm going to go along. I'm going to go along and redesign some coils around these things. But my existing coils, these round ones, they stick out the bottom of the generator, so they're a little bit too thick. So these are actually two round toroidal core bobbins, which means two toroids fit inside each one of these, and that's going to be a little bit thick to get inside the assembly for the drawer and everything. So what I'm going to do, but because I'm using three coils to dry out the system instead of just two, which is what I was using before, like here, I'm thinking, well, I'm going to get away with one core per coil. So I'm going to redesign, I'm going to make some specific coils that will fit inside these drawer sections, so that the actual diameter is quite good. The magnets, which I'm using to amplify the actual drive signal, I'm going to move them to these slots, which aren't really used except for cable routing. So I'm going to make some adjustments I'm actually making adjustments in SketchUp at the moment. So I'm going to accommodate, these coils are going to sit a lot lower down. I'm going to get rid of these magnet slots, which I've put in here, which is what's in here. I've got magnets in the base there. So instead of having magnets directly around there, they're going to be in these slots. I'm going to move them outside a bit. Then this can fit further down. So I keep forgetting the camera's on the right hand side. I've got the phone upside down. Actually, let me just turn it around, then I won't get so confused. Right, that's better. So if I do away with these, I can put thinner coils, same kind of diameter. I'm going to sit these very low down because I need to get them as low as possible, because I want to have room to put my lamination array on top. So I've got my propulsion coupling between the coils and the rotor drums. So this is what I'm going to do the next phase, because these do work very well. There's very little drag and cogging with them. So this is where I'm at the moment. As I say, this was an interesting test, but they started to overheat again, because they were just not efficient enough, and because of the lack of efficiency, I was having to push more current into them, and they just didn't have the thrust, the drive capabilities. As you can see, that plastic there started to melt a bit. I don't know if you can see it, but it's actually started to melt a bit because it was getting hot and the heat can't get out. So there's another issue I was thinking about as well, which is to in the bottom of these drawer sections is to put some slots on the back. This is the bottom, you see. So I'm going to run some slots possibly where I can stick some steel laminations on the back and have a heatsink on the end to dissipate heat. Now that's one possibility. Now the only issue about doing that is it could interfere with the flux and everything. So I'm thinking about ways of doing that, possibly using aluminium. Well, aluminium, even that has a lensing effect on magnetic rotor drums, but what else can you do? You've got to use some kind of material that will dissipate heat, and the only thing that will really dissipate heat thermally is a metallic structure. You can't use anything else unless I went to water cooling. Now that's an issue I thought about. What about installing some water pipes, some tubing in the bottom there? But then that would require a conduit, a thermally conductive conduit that could hold the water inside and conduct the heat away, and that would end up being copper pipe or something else, and that's still a problem, so I can't win. And the other thing I could possibly just use is a plastic pipe, but the thermal conductivity of plastic is very low, but it would still help dissipate heat down water. But it's not very, even water's not very conductive, and it would have to be flowing really to be ideally effective, and then I would need a water pump. Yeah, it just gets really complicated. So anyway, I'm still thinking about that, about ways of dissipating heat, but ultimately, that won't be a problem if I can make the damn things more efficient, much more efficient drive-wise, so that my current consumption goes right down. So ultimately, the objective is to get the current consumption as low as possible. Then I won't have this thermal problem. So it's kind of a it's a kind of a sidetrack really, because this this thermal problem is really all about the fact that these particular coils and arrangement. These thin coils, which I made a few years back, just are not very efficient. So what I did find was that these were very efficient. This is one coil which I wound, which never got melted. I wound it like the others. Where's the focus? Not very good. I just don't know. So anyway, this particular coil which I wound, I could wind some more like this thinner. Have 3 instead of 2. I'd like 4, but I've got a trigger coil at this end which move back and forth to adjust the timing. The only other thing I could do is to extend this and add another section onto the back end, which I could easily do to have my trigger coil. I could have 4 driver coils. I could have 1 drum on the end as my trigger coil for the trigger coil circuit, which is possible. I might think about that. Because I've got a bit of drive shaft sticking out, you see. So I can easily add another section on, but then that's going to add more weight to everything. Anyway, so there's things to think about. I mean, obviously, the whole purpose of this is to make it more efficient, have less drag on the output section, and have more drive force on the input section with minimal input current. And so this is what I'm trying to resolve at the moment. I wasn't going to make this video earlier. I thought, well, bugger it, I kind of feel disappointed that these didn't work, but then I thought, well, I really knew they wouldn't work very well because I actually wound these coils a few years back, and they weren't really designed for this. They were designed as output coils really, but I was kind of hoping that they would work. But yeah, they work, but there's about 60% efficiency compared to these coils. So yeah, the RPM I was getting out of these 3 was about 3,000 RPM. It's about 3,500 RPM, but that was a ridiculous current of about 600 milliamp peak. It was around 500 milliamp when they got up to speed, but when I stuck a load on, the current would go up to like 600 milliamp. Well, that's ridiculous. That's way more than what I was pulling earlier. I mean, I was down to something like 410 milliamps with the other coils and with a load on. So the other coils were definitely better, you know, like these types, the ones that are melted. So anyway, yeah. So I'm going to be going back in SketchUp. I've actually started already in the model. I've lowered all these magnet things. I've basically left it bare bones right now, so I can have a think about how to do this, because I did think about doing square coils, rectangular coils with a round core material in the middle, but yeah, that would probably be less effective, because where the coils are further away from the core material, you'd lose flux to coupling between the coil wire and the actual coils. So I'm going to stick with the round ones, I think. I'm just going to make them thinner, and then I'm going to have my magnet couples in these slots that aren't really being used apart from wire threading, which can be a lot narrower because I don't need all that space for the wires. Plus the wires can actually be threaded. Well, they don't need a lot of space. I might make some special slots for the wires to run through, so I can keep them separate from the magnet sections and everything else. But now I've got a problem of getting those magnets out of there, because with the heat the plastic's bulged out a bit, and it's going to be a trick to get the magnets out of there now. More problems, but I'm not worried too much. I mean, I probably won't be using I don't know if I'm going to be using these magnets again for this particular job, because I might end up using different magnets. I might use these longer magnets. I don't know yet. I have to think about it. But these little magnets, I do like them, because they're easy to find little spaces to get them in. You see, they don't take up so much room. Anyway, that's all for now. Yeah. So I'm going to watch some snooker and chill out for a bit, and while I'm thinking about things. And but laminations definitely make a big difference. It's just making room to get them in there without them fouling on the draw as it goes in the slot at the side there at the bottom. So when I slide the draw in, oh well, I might as well show you anyway, just in case you didn't watch the previous video. But they just slide in like this, yeah, into the bottom of the device. It makes it easy to swap them out, and it's good really, because it means I can make multiple draw assemblies with different coils and swap them out quickly, and especially useful because if they do get too hot, I can literally whip them out and cool them. And I did measure, I took these out yesterday. I was doing a test, and they got up to 112 Celsius, which is way too hot. 112 Celsius. The middle one was about 112. The coils on each side of that was about 100 or 98 Celsius. So they were getting way too hot. So they do need some sort of cooling. Now I could blow a fan, stick a fan on the end, make some little holes and just blow air all the way through. Now that is a more practical idea. I have actually got some small fans. So yeah, I could quite simply just put some slots with holes all the way through and blow air all the way through there. Now that's possibly the best way of doing it, air cooled, rather than adding steel laminations and everything else to soak the heat out and take it to the outside. Just simply blow some air through there. Now that is a feasible thing, but then that adds more current on the output. It means I'm going to be using more power. So yeah, but they might not need that much power. I mean, it might just be a simple, because the thermal situation is that the heat doesn't happen suddenly. It builds up because this is a very insulated, tight space, and air can't get to it. So the thermal situation is that it might take 15, 20, 30 minutes for it to get up too hot. So it might not require a lot of air cooling. It might simply be that it's getting thermal runaway, which you know that is where the heat just builds up and up and up and up very slowly, and it gets to a thermal maximum, and that's when the plastic starts to warp and everything. So it might just need a steady flow of air running through there, a few milliamps, say a 50 milliamp fan or something like that, just to keep it cool. So I'm thinking about that as well. Designing it so that I've got some little holes and a fan mount on the end where I can just blow the air through. Or I might stick a fan mount on one side and install the draw from the other side, which makes life easier because it means I don't have to keep I don't have to keep removing the fan all the time. The fan's going to be attached to the other end. So yeah, that's another thing I could think about doing. So that's it for now. Just so you know what I'm thinking about.